If Australia's farmers are to play a part in reducing the country's greenhouse gas emissions, then some predict that storing more carbon in the soil will be one way of achieving that. The Carbon Farming Initiative before Federal Parliament will let farmers sell carbon credits if they can show they've stored extra carbon in their soils. But before they can do that, there needs to be an accurate way of measuring soil carbon across the country.
There are some who believe the country's soils hold the key to dealing with Australia's greenhouse gas emissions. Carbon is stored in soil just as it is in trees. But to date, it's trees we think of mostly as carbon sinks.
Trees have been important initially because the science that underpins it is well proven, and it takes a long time to get good science to give you the confidence to invest in a technology, and it's cause and effect really. There's not been a strong economic driver over the last 20 years to have a huge body of soil carbon science undertaken.
If the federal government's carbon farming initiative becomes law, farmers might one day be paid for storing extra carbon in their soil. But before that can happen, we need a better idea of how much carbon the country's agricultural lands hold.
Soil carbon, what we don't know yet is, firstly, how strong is the science? So how much carbon per hectare in a variety of landscapes is actually sequestered, the permanence of that sequestration, so it's not just cycled out of the paddock and into the atmosphere.
So we've got the points picked out.
Most farmers know the value of soil carbon, even if they don't know how much carbon is in their soil. Soils that are high in carbon are usually more productive.
Random selected 40 of those, which we're going to sample today. We've got GPSs of them in advance, and that will give us 120 samples in total as we're going to measure at 3 depths.
Right, let's get it going.
Jeff Baldock and his CSIRO colleagues are measuring the carbon content of soils.
We're going to a little over 3,000 different sites around the country, and we're implementing a sampling program like this where we'll go and collect a minimum of 10 samples from each of those paddocks we visit.
There are different ways of taking samples.
This spot.
From mobile hydraulic core samplers to this more painstaking manual method. But accuracy is important, and care needs to be taken, since these small samples will ultimately be used to calculate tonnes of carbon per hectare.
Okay, and then we'll clean this bit off the outside so that it doesn't contribute to the actual sample we're trying to work with.
Each of the samples will go back to the lab to be analysed for organic carbon.
We talk about particulate organic carbon, which is really partially decomposed little bits and pieces of organic matter that we may or may not be able to see with our own eyes. Sometimes we need magnifying glasses of some kind to see them. The next fraction we look at is something we'll call humus, which is the really well decomposed stuff. And that tends to be more molecules or dominated more by organic things stuck on soil particles. We don't see the structure of a root anymore or the structure of a leaf. It's been broken down to that extent. And the last form of carbon we look at is we're calling it resistant, but it's really dominated by charcoal in the Australian context.
So they're taking samples at 3 depths. That'll give an idea of the different types of soil carbon at different sites and how they might change over time. The different colours of the 3 soil samples is a rough guide to the different types and densities of carbon.
So when we're trying to work out carbon accounting and understand whether a particular management practice, such as the one that's been employed here, has a chance of shifting soil carbon values around, by doing this staged approach, we get a little bit more detail than we would have if we'd just taken a single sample.
CSIRO's Soil Carbon Research Program will link these carbon values to soil type, land management and other factors like rainfall.
When we put that whole data set together, it'll give us a really good idea of what the low end and the high end of carbon contents are under the management regimes we've looked at. That hasn't been available to us before.
That'll give farmers a baseline to measure the carbon on their own properties. But here's where the government's plan for farmers to earn and sell carbon credits meets arguably its biggest practical barrier. If you store additional carbon, you have to guarantee it's stored for 100 years.
So that's the permanence rule. And I think there's a caution to be had here in that soil carbon, for example, you can lock it up over 5 good years of rainfall. You can have soil carbon build up because the rain is allowing more productivity, it's allowing more organic material to go into the soil. It's out of your control, really. But then you go into 5 years of drought, like the last 12 years that we've had, and that equation goes into reverse. Out of your control, because water is determining the limit, you could actually lose carbon. Now, if you've sold that carbon, someone else owns it. And while the government has some methods to allow that you don't have to actually pay it back, you have to just demonstrate that the buyer still has their carbon. So I think that's a risk.
Ian McClelland runs a sheep and cropping enterprise in the Mallee. He knows there are ways of farming to increase the carbon in his soils, but would he want to sell carbon credits?
I personally think that carbon's too important a product to sell to store it for 100 years. And carbon is money in the bank for us because it's converted through microorganisms to fertility.
Even if you want to store the extra carbon and sell the credits, what might be an asset to one generation could turn into a liability for another.
See, the other problem is if you put down carbon and you get paid $20 a tonne for that carbon, and in 30 years' time you want to do something else on your farm which might reduce that carbon and you have to pay it back, but meanwhile the price of carbon goes to $200 a tonne, you're putting a chain around your grandchildren's necks, which I think is not really what I want to do.
The rule about permanently storing carbon is farmers' most persistent criticism of the carbon farming initiative. Near Gundagai, Sam Archer is an enthusiastic tree planter. It's part and parcel of the way he chooses to farm. He's not doing it for a carbon credit.
I think there needs to be clear cost benefit. If that's there, then farmers will take that on board and make decisions around how their farming system looks and whether they've got opportunities to be planting trees to sequester carbon.
He doesn't believe the government's carbon farming legislation reflects farm management realities.
We work in a very dynamic and fluctuating landscape over which we have some control but not a lot of control, and therefore the complexities need to be reflected in the legislation to enable us to manage within that dynamic system.
The carbon farming legislation before Parliament does recognise that some things are beyond a landholder's control.
For something like forestry, where you might get fires, well, you won't be penalised for a fire. You'll have a stall on your credits potentially, but the government wants to ensure that if you change your land use to forestry, that it stays there as forest for 100 years.
Andrew Macintosh specialises in environmental law.
There's a real tension between ensuring that the credits are additional, so that means that they have environmental integrity, that you're paying for something that is different, and imposing too many burdens on the farmer. Because if there's too much to do, too much for the farmer to prove, it's going to pose too many costs on the farmer, and the farmer is just simply not going to be involved in the scheme.
Andrew Grant runs CO2 Australia, which plants trees for companies that want to offset their greenhouse gas emissions.
My view is that the agriculture sector should be excited by this opportunity because its ingenuity and entrepreneurship and really sophisticated management practices that it's brought to a whole range of other commodities will similarly be deployed around carbon.
He believes there'll be plenty of ways of generating carbon credits.
In intensive agricultural operations, say feedlots or large-scale animal husbandry operations, there will be methane capture programs that are cost-effective that will generate good carbon credits. And nitrous oxide similarly has a much higher global warming potential, so its value as a carbon offset is much greater again. So I expect this is why we need the rules and the regulation to enable project participants to go out and find these economic projects.
Even if the carbon farming bill becomes law, it's voluntary, and without a price on carbon, it probably won't mean much. Its supporters concede it's a difficult area to regulate.
So this is a very complex thing to do, and that's why we're on baby steps right now. The CFI is going to be a first step in what promises to be a very long process.
Sam Archer's sceptical about the carbon farming initiative.
So what do you think it would take to make the carbon farming initiative really work?
I think there needs to be a lot of education. Farmers need to be aware of what they're getting themselves into, and there needs to be a price that is cost effective for them to contemplate doing it and moving from their existing farming system to this changed one where they're looking to capture carbon.
The government hopes to have the legislation through Parliament by the end of the month.